Hello everyone, welcome to Environment Technology NewsHour. Saurigrap, Namaskar. This is a weekly online program on environment technology, and this program happens on every Tuesday. I welcome you all. As you know, this program is managed and owned by Technobase. You can always find more information on Technobase at technobase.org. Let me quickly brief you about what is Technobase, what kind of services we offer. Technobase is based in Thailand, established in 2005. It is recognized as International Resource Center for Industries and Technologies. The main pillar of Technobase is the professional education, and along with that one, we offer a number of business services. When it comes to services, we organize trade exhibitions. We also offer the training and conferences, webinars. We have business networks. We have publications. We also offer technical consulting and also marketing and branding support as well. Okay. But when it comes to the business focus, we have two segments, polymer and non-polymer. When it comes to polymer, we cover on the rubber industry, plastics, polyurethane adhesives. Non-polymer is a chemical engineering, water and environmental membranes, filtration, separation, etc. So it's all related to the, these services are related to the education side or the business services. We also have these exhibitions for Membrane and Filtration Trade Expo, which we are organizing next year in March, 29 to 31st March. And we have the Recycling and Recovery Trade Expo, which is also same time during the same period and the same venue. So we have 2 shows happening in March next year. I welcome you all to participate in these trade shows. We do have developed online training programs focused on the membrane filtration. Currently, we have developed 32 modules which focus on the ultrafiltration, microfiltration, reverse osmosis, desalination, membrane bioreactors, and also the ceramic membrane. So these are available on schedule as well as on demand. You can always check these programs availability of the schedules and on demand at our website, knowhow-webinars.com. Knowhow Webinar is a project of Technobase, which is a focus on the online professional education. We have these books available from the Technobase store. Currently, these membranes, desalination. You can always check details on how to purchase them at the store.technobase.org. So let's welcome you all for this episode number 16 on Environment Technology NewsHour. And today our topic is focusing on the bioelectrochemical cell for toxic wastewater treatment. This presentation will be given by Mr. Vijay Samuel. He is an assistant professor in the Department of Chemical Engineering at Hindustan Institute of Technology and Science in India. Let me brief you about Vijay and his expertise and specialization. He is a biochemical and environmental engineer. He is, currently, as I mentioned, he is an assistant professor in the Department of Chemical Engineering, Hindustan Institute of Technology and Science in Chennai. His research interests are focusing on the waste management, environmental health and safety, bioremediation, and bioelectrochemical engineering. He holds an international patent on system and method for a simultaneous removal of organic pollutants and heavy metal from wastewater. He has received many awards from a number of prestigious institutes in India. He has authored 14 research and review journal papers and also contributed 3 book chapters. Currently, he is pursuing PhD in bioelectrochemical engineering. He is also an active member of professional bodies like Indian Institute of Chemical Engineers and also Chemical Industry Association. So that's briefly about the Vijay, and I invite Vijay to make a presentation on the bioelectrochemical cell for toxic wastewater treatment.
Okay, hello. My presentation is on bioelectrochemical cell for toxic wastewater treatment. Okay. So to get started, let me brief you on case studies. This is a huge industry which was closed in way back in 1995 by Pollution Control Board norms. The name of the industry was Tamil Nadu Chromates and Chemicals Limited, Ranipet, and you can just see the abandoned site of it. So where me and my research team, we visited that place, and there are a number of other research teams that visit this place for their research on leather industry toxicity and treatment. So this industry was commissioned in 1976. The TCCL was involved in the production of sodium dichromate, basic chromium sulfate, and sodium sulfate. It stopped manufacturing in 1995 and has been abandoned since then. An estimated of 1.5 lakh tons of chromium-bearing waste continue to remain there, posing a serious health threat. Chromium is a heavy metal and causes cancer. It is estimated that already it has contaminated groundwater in a 30-kilometer radius in the district. Water has turned yellowish in several localities. Another case study, chromium, the metal, is a major pollutant impacting air, surface water, groundwater, soil, and human health. It was first introduced in steel plants during the colonial period in 1865, and its use became prominent in leather industry since 1884. Another case study in Kanpur, the toxic cause of Kanpur's leather industry. In a compelling visual narrative, independent humanitarian documentary maker and photojournalist Sinduja Parthasarathy highlights the precarious plight of the industrial suburb in Kanpur that houses close to 400 leather tanneries. Now, the heavy metals, they refer to any metallic chemical element that has a relatively high density and is toxic or poisonous at low concentrations. Chromium, arsenic, mercury, lead, thallium, etc. They are some examples of heavy metals. So they are natural components of the Earth's crust. They cannot be degraded or destroyed. To a small extent, they enter our bodies via food, drinking water, and air as trace elements, which are very essential for our body metabolism. Metabolism, like copper, selenium, zinc, which are essential to maintain the metabolism of the human body. However, at higher concentration, they lead to poisoning in terms of bioaccumulation, biomagnification. Bioaccumulation is the increase in the concentration level of heavy metals in a single organism. And biomagnification, it is the transfer and the increase of concentration of heavy metals from lower trophic levels to higher trophic levels, as you can see in the pyramid. Now, heavy metal poisoning could result, for instance, from drinking water contamination, like lead pipes, high ambient air concentrations near emission sources, or intake via the food chain. So, hexavalent chromium in industrial wastewater, let's see what it is. So, hexavalent chromium is present in the wastewaters of a number of industries producing steel, chrome-plated products, tannery products, dye stuff, paints, etc. So chromium discharge in tanning industry, like the raw leather is first treated, and it gets into pre-tanning process. There are two types of secondary treatment, which is vegetable tanning and the chrome tanning process. The vegetable tanning is the conventional method, and the chrome tanning is a newer method wherein high amounts of hexavalent chromium is used to degrease, pickle, tanning, press, and dry the hides, and then they come out as finished products. Now there are uh, three main stages of leather tannery treatment for operations in leather tannery process. The first one is the beam house operation. The second one is a tan yard operation. The third one is a finishing operation. Our research will mainly focus on the beam house operation and tan yard operation, because the beam house operation, there are different stages of effluent discharge. It is not single effluent coming out as tannery effluent. There are three stages of effluent discharge. The first stage is the beam house operation, wherein you get a lot of organic pollutants in terms of high in BOD, in terms of it could be the flesh, the blood, and all the body components, or the flesh and the blood components of the hides. Okay, now the second one is the second stage, wherein you add a lot of hexavalent chromium dyes, and then you have this hexavalent chromium discharge. These two stages are very important for our research point of view, because the organic pollutants are being treated as they are taken as anode or the anolyte, and the hexavalent chromium effluent is being treated as catholyte. So these are the two operations we'll be working on in our research. So as you can see, the tanning process and the tanning industry effluent discharge into the ecosystem. Now how brave it is, and this is how the industry looks like, and this is how the discharges are taking place into the water bodies. So based on the concentration effluent, according to the environmental protection rules of 1986, the highest accumulation or the highest concentration is 10 milligram per liter, and that too in marine coastal areas. It is not in inland surface waters, but then it is the marine coastal areas can have only 10 grams, 10 milligrams per liter, okay, of hexavalent chromium being discharged. But then let's see what's happening. Like, chromium can exist in several chemical forms displaying oxidation numbers from 0 to 6. Trivalent and hexavalent forms of chromium are the most stable in the environment, and industries are discharging about 390 milligram per liter of chromium. Just industries alone. It is not the inland waters, or it is not the marine coastal areas. So every industry, per industry, the discharge is around 400 times more than the prescribed limit of the pollution control board. Okay, so that is the grave situation that tanneries are now causing to the society. And the toxic impacts of hexavalent chromium could be allergies, irritations, eczema, ulceration, nasal skin irritations, perforation of eardrum, respiratory tract disorders, lung carcinoma, genotoxic and mutagenic effects. So there are various treatment processes which are available in the market, and the industry is ranging from your conventional activated flush process, anaerobic treatments, constructor wetlands, sequence batch reactors, and then you have membrane technologies, and then moving on to sequencing batch biofilter granular reactors. Okay, so our focus is on bioelectrochemical cell, more popularly known as microbial fuel cell or MFC. So this is still in research stage, and this is now in the laboratory scale, and it will take a couple of more years to come to the commercialization stage, and we are working on that. Right now we have a couple of industries which are interested in the project, and we hope to commercialize after obtaining successful and the desired results. So as you can see, this is a double chamber or a two compartment microbial fuel cell. The working volume is around 500 milliliter as of now, because we need to get repeated results. So we are confining the volume to 500 ml. And you have the anode chamber and the cathode chamber being separated by proton exchange membrane. So the anode chamber has the anode, and the cathode chamber has the cathode as electrodes. And then you take the organic pollutants into the anode chamber. You take the hexavalent chromium effluent into the cathode chamber, and then as catholyte. So now what you do is you take up the microbial consortia from the raw effluent of the tannery, and then you introduce them into this anode chamber, wherein they react with the organic pollutant. They consume the organic pollutants as the substrate. Under such circumstances, the levels of organic pollutants get reduced to desired levels. Now, after these bacteria, these useful bacteria, they feed on these organic pollutants. They release energy in terms of electrons and protons. The electrons travel to the outside uh, circuit, and they produce electricity, and then the remaining electrons, they travel to the cathode. Now the protons which are produced, the H plus ions, they travel to the through the semi-permeable membrane. They enter into the cathode chamber. Now the electrons which are traveling from outside, they enter into the cathode chamber. Now what happens is you have this hexavalent chromium molecules which acts as what do you say, electron acceptors. They accept these electrons, and they get reduced into less harmful trivalent chromium, which are deposited on the electrodes or the cathode. Okay, now the H plus ions travel to the cathode chamber. They mix with the oxygen which is passed into this reactor, and they combine, and pure water molecules are produced. So you have a dual purpose of being clean, dual research of being clean energy produced, and also the pure molecules, the clean water being generated. So there are two kinds of activity which is happening. One is the production of clean energy in terms of electricity, and then the other is the formation of the quality and the pure oxygen water molecules. At the same time, you can also recover the heavy metal which is being deposited on the electrode. Okay, so there is a metal recovery process also is happening. In fact, it is not a dual work. It is like, you have this three tasks, being performed in the single reactor. Okay. So MFC, or the microbial fuel cell, is a bioelectrochemical device in which microorganisms oxidizes the organic matter produced in the effluent and produce the electrical energy, and simultaneously treats the wastewater. So your uh, your analyte could be anything, anything which has high BOD content. Okay, which is biodegradable. Especially, it could be the tannery effluent, it could be municipal wastewater, agricultural wastewater, dairy, brewery, whatever it is. Something that has a substrate for the microbes to work on, to feed and to produce electrons. Okay, and moving on to the next slide. Okay, so there are various microbes which have their own preferences of substrates. So, like, if suitable substrates are being provided to these microbes, you can get maximum electricity production. Like, E. coli likes glucose, Bacillus subtilis likes glucose, E. coli again likes acetate as substrate, then Pseudomonas methanacea, methane, Proteus vulgaris, sucrose. There are a lot of substrates that can vary. So you can add, or you can supplement the substrates with these kind of uh, the compounds which are suitable for the microbes to produce more electrons or the electricity. Now, what are the advantages of MFC? Like, you have useful product in the form of electricity and hydrogen. No aeration is needed for an air cathode MFC that uses only passive oxygen transfer of the cathode. Reduce solids production, potential for odor control, clean and safe. The technology is clean and safe, low emission and high efficiency. It does have limitations, like the power output is relatively low, so you can use like voltage booster to increase the power, or you can have cascade of reactors to increase the power outputs. Technology is only in the laboratory phase, so as I said earlier, it is in laboratory phase. It has more time to go to into get into commercialization. Then you have this potential difference between electron donor and acceptor gives maximum potential difference of 1 volts. The voltage output has to be increased. However, by linking several MFCs, as I said, if by linking a cascade of MFCs, the voltage can be increased. Now, there are various types of MFCs which are existing in the research laboratories. You have this one-chambered MFC, two-chambered MFC. You have this upflow mode MFCs. You have stacked MFCs. And then you have the salt bridge MFCs, batch mode MFCs, continuous flow MFCs, photoelectrotropic, photoheterotropic MFCs. Then you have single chambered MFCs. Then you have H-type double chambered MFCs. It all depends on what kind of results you want, what kind of effluent you need to treat, and what is the desired result. So the MFC construction varies from case to case basis. It is not that one single microbial fuel cell works with different effluent and works with different results. And then what are the applications of MFC? You have electricity generation, wastewater treatment, and recovery of pure materials, removal of organic matters, as in our case. Then you have electricity generation, obviously, like we do the same thing, wastewater treatment, recovery of pure materials. And then you have treatment of specific pollutants. It is a bioremediation process, heavy metal recovery, dye decolorization. We thought we will try it in our future work on textile industry effluent as well. Then water softening, biogas production, biomass production, robotics, biosensor application, in situ power supply, implantable power supply. So you have a lot of research being done on metal recovery. You have a list of metals being projected here uh, in the research paper, which was published in 2014. You have aluminium, antimony, arsenic, barium, bismuth, cadmium, calcium, chromium, cobalt, copper, gold, iron, lead, so on and so forth. And then a different process needs different electrodes. So the electrode materials, they can be same. The cathode and anode can be same, or they can vary based on your desired output, as I said. ranging from carbon paper to graphite plate, carbon cloth, carbon mesh, granular graphite, granular activated carbon, carbon felt, reticulated vitrified carbon, carbon brush, stainless steel mesh, etc. I use carbon paper for my research, and the granular graphite is the costliest of all the electrodes. So if there is heavy funding, then you can again go for the higher capacity, the high performing electrodes. Okay. Then now, what are the bacteria which are working on this? What are the kind of bacteria that you need to isolate from the raw effluent in order to feed them as microbes for treating your wastewater or the toxic water? They are Bacillus, Pseudomonas, Streptomyces, Artobacter, or Arcobacterium. Then you have this Burkholderia. Then you have this Providentia. Then you have Exiguobacterium, Leucobacter, and so on and so forth. There were researches which were done on pure isolates and mixed culture, and it was shown that mixed culture MFC showed relatively stronger response to current generation than MFCs operating with plain wastewater with monotype isolates. So like it is a synergistic performance of microbes which are working on this wastewater. Now the reaction is as follows. Since acidic, as I said, like the hexavalent chromium, they act as electron acceptors. So the acidic hexavalent chromium can be used as cathodic electron acceptor in microbial fuel cells. It makes it possible to reduce hexavalent chromium to much less toxic chromium, which is trivalent chromium, with simultaneous electricity generation in a microbial fuel cell. Okay. Now, what actually happens when a bacteria is feeding on the hexavalent chromium, or when the hexavalent chromium enters into a bacterial cell? So this is the biochemical reaction which is being projected to you. So the hexavalent chromium and the trivalent chromium are the two most stable forms of chromium. Then Cr6 plus is highly mobile and permeable. Complete inhibition of sulfate transportation system takes place. The hexavalent chromium enters into the bacterial cell. Sulfate is replaced by hexavalent chromium during transport. Now the reduction of hexavalent chromium to trivalent chromium via chromium 5, chromium 4 through electron transport chain in the cytoplasm takes place. There are several ways bacteria can withstand chromium toxicity. One of the best method is the usage of chromium reductase enzyme that will convert this hexavalent chromium to trivalent chromium. Some of the common proton exchange membranes are, which are used. I was just talking about the semi-permeable membrane, which acts as a, divider between the anode and the cathode. And there are a number of, proton exchange membranes which are used in the market and the research, that is Nafion, ultrafiltration membranes, Ultrex, salt bridge, clay, speak. The salt bridge is the cheapest of the lot, but then the desired outputs are not up to the expected level. So the costliest of the lot is the Nafion membrane, which is predominantly used in most of the researchers so far. In our research, we are taking the speak membrane, which is relatively less costlier than Nafion. So this is speak is nothing but your peak first, that is which is like polyethyl ethyl ketone, and then this we are taking and sulfonating it, and hence the name speak is derived. Okay, so Nafion membrane, so it has high proton conductivity. The reason why the Nafion membrane was used is because of its high proton conductivity. It is also referred to as PEM on the basis that it is designed to transfer H plus protons. So your speak is nothing but your polyether ether ketone is a promising candidate actively being researched for fuel community to overcome the drawbacks of Nafion. Speak is a low-cost polymer with good thermal stability and mechanical properties. Proton conductivity for this polymer is achieved by sulfonation, and hence the name speak. The sulfonation is about 1 week process, which comprises of adding concentrated sulfuric acid at desired concentrations, then drying it, then washing it, and then again reheating it, and again drying it, and casting it, and making it as a membrane. And then you have this higher mechanical stiffness of the polymer backbone in the case of speak, which is attributed to the presence of aromatic group. Such types of electrolytes have a potential to influence MFC performance. So like, hence like we are zeroing down on our research tab, which is like wherein like SPEAK is mainly used as proton exchange membrane. Now, salt bridge is used instead of Nafion. As I said, the power output is less. Then the research is also made on Speak, which was producing higher output. Then why we are choosing a double chambered MFC is because the reduction of chromium was reported to be more. Okay, so hence we are using this double chambered chromium, and we are replacing Nafion. We are replacing Speak instead of Nafion as our proton exchange membrane. Now, these are materials and methods. The working volume, as I said, is 500 ml of effluent, and we have designed this using the CAD, and this is a reactor diagram wherein it consists of the reactor material is used as acrylic material. The acrylic material is used as the reactor material, and you have the cathode and the anode chamber being separated by the proton exchange membrane, and then it is externally connected by the circuit. And then you have this peak synthesis in process, and this is how a laboratory synthesized peak will look like. It is the perfect peak will have an amber colored as it is amber color actually. Now we had a number of analysis which was done, and if you can see that the hexavalent chromium reduction, we used atomic absorption spectroscopy for this analysis, and after a hydraulic retention time of 15 days, we used a comparative study between Nafion 117 and Speak, and we found that there was a relatively more reduction of hexavalent chromium for Speak as PEM when compared to the Nafion membrane. So Speak was the desired proton exchange membranes, and then we subjected the wastewater to water quality analysis, and we could see there was a considerable reduction in BOD levels in Speak and COD levels, as well as there was an increase in dissolved oxygen level when compared to that of the Nafion. Okay. We also subjected the microbes, the raw effluent, the microbes, five pure isolates were isolated from the raw effluent of tannery industry, and they were subjected to 16S rRNA sequencing. And after that, the sequencing were found using, blast search using NCBI database, and the gene sequence were fed into GenBank. Okay, and this is the species that we found out. It is Enterobacter formicae and Acinetobacter baumannii. Then we had the Streptophonomonas maltophilia. Then you had Pseudomonas aeruginosa. So these are the 5 different gene sequences that we obtained, and these were the microbes which were predominantly acting in the production of electricity and the reduction of hexavalent chromium to trivalent chromium. This is the scanning electron microscope image of the anode, which shows that there is a clear deposition of microbes on the anode surface, and this is the phylogenetic relations of the stains used in the study that is being depicted as phylogenetic tree. Okay, so the next level of research is the incorporation of nano composites on the membrane, Speak membrane, that is desired to give better reduction and better output of electricity. Due to the exceptional characteristics which resulted from nanoscale size, such as improved catalysis and absorption properties, as well as high reactivity, nanomaterials have been the subject of active research and development worldwide in recent years. Numerous studies have shown that nanomaterials can effectively remove various pollutants in water, and thus have been successfully applied in water and wastewater. Some of the desired nanomaterials are, silver, iron, zinc, titanium oxide, zinc oxide, iron oxide, carbon nanotube. So we thought we'll be using carbon nanotubes for our, research purpose. And as you can see, this work was, patented as, system and method for simultaneous removal of organic pollutants and heavy metal from wastewater. This is an international patent that we received for our work. And as you can see, 2 sustainable goals are met in this project. That is, clean water and sanitation, affordable and clean energy. These are the sixth and the seventh goal of the sustainable goals were met in this project, or are met in this project. And I would like to acknowledge the following, people who are involved in the research. Dr. A. Anita, Professor, Department of Chemical Engineering, Hindustan Institute of Technology and Science. Dr. Govindarajan R., Assistant Professor, Department of Chemical Engineering, Hindustan Institute of Technology and Science. Dr. D. Sangeeta, Associate Professor, Department of Mechanical Engineering, College of Engineering, Anna University. Dr. T. B. Sridharan, VIT University. Then my students, Akash, Vikash, Roshan, they are UG students who are working with me in this project. So water is a driving force of all nature. And with this, I conclude my presentation. Thank you.
Thank you, Vijay. Excellent presentation on the MFVCs. Good. So let's have a short discussion about the, your presentation and also the activities you are doing. First of all, excellent presentation on the bioelectrochemical cells. I understand that it's a multifunction, metal recovery, energy recovery, and also clean water. You said that in its congratulations that it's patented your work. That's super, and covering the SDGs. So excellent. I'd like to to have a short discussion not only about this topic but also your institute. So doing this kind of work is because you have the facility at your institute. So can you talk a little bit about this Hindustan Institute of Technology and Science, what kind of programs they offer, what kind of research is going on, or what kind of infrastructure is available? Any industry would be interested to collaborate, with you or with your colleagues, in the institute itself. Yeah, please.
So I work with Hindustan Department of Chemical Engineering, Hindustan Institute of Technology and Science, and I'm very proud to be a part of it because, this was started in the year 1985 by a visionary called Dr. KCG Varghese. And it was predominantly, this is mainly Hindustan Institute of Technology is one of the premier private institutes which is known for aeronautical engineering and aeronautical sciences. Okay, next to MIT Chennai. So, and then we have other programs which are in parallel to it. You have computer science programs, then you have this mechanical engineering, automobile engineering, so on and so forth. And chemical engineering and biotechnology department are as a department together, wherein I work as a faculty. And we have a number of facilities with us, like in terms of gas chromatography and other PCR facilities with us. And we collaborate with a number of industries like soft gel, Biocon, and we also collaborate with a lot of have a lot of professional body associations like Indian Institute of Chemical Engineers, and then chemical industry associations, then Society of Biological Chemists in India. So that is how it is. And we are given a lot of freedom to carry out our research and to publish them in journals, and then attend faculty exchange programs, and give our presentations in a lot of public forums. And I'm really proud to be a part of it. And over the years, I must say that after coming to HITS, my CV has really improved to a great lot of extent. And that is my journey about. And it is mainly HITS focuses on project based learning for students, because earlier in our times, it was only after 4 years you get to feel the industry or you get to look at the industry. But students right from their third semester onwards, they are being assigned design projects, and their faculty or the mentor who work with them on the project, and they bring it forth. They apply for a lot of competitions and techno competitions. They try to commercialize that, and try to bring it up to the industrial scale right from the bench scale. And we as mentors train students, mentor students, and work with them. So there is a lot of student faculty connect which is happening in the institute.
Super. Good to know about the HITS. I like the abbreviation HITS, HITS. So Hindustan Institute of Technology and Science. So I understand that you do a lot of research, industry-oriented research or industrial problems. So that makes the students also, whatever their coursework they do is relevant to the, industry requirements. That's very nice of it. Okay. So you guys offer what kind of programs? Bachelor, masters, and PhDs in your institute? What's like?
Yeah, there are a lot of departments offering masters. So relatively chemical and biotech is a newer department. As of now, we offer UG programs, that is like, BTech in chemical engineering and BTech in biotechnology, with honors as energy management for the chemical engineers and genetic engineering for the biotechnology student. We also offer, PhD programs. I'm a PhD student, with the Hindustan University.
And you said that you have a good infrastructure, and other than your MFCs, so what else research is going on at the HITS in your department,
in my
along
department,
with other
yeah,
professors or
my
other
colleagues,
faculty?
yeah, most of my colleagues are from NITs, IITs, and abroad, and they work on a lot of microbial research, and then like waste management research, wetland process, and membrane research, biofuels, biodiesels, bioethanol production. Dr. Anita, she specializes in that. So there are a lot of people working on various aspects of chemical engineering and biotechnology and biochemical engineering.
So it's related a lot onto the renewable energies and alternate energy sources. Yeah, so super.
More on that.
More on that. Yeah, I
And
think that's
nanotechnology. And nanotechnology.
nanotechnology. Yeah, I think the needs of the current requirements, right? So these areas. Yeah. Super. Okay, let's talk about your presentation, MFCs. And you showed nice picture of the, well, it's not a nice picture, but it's a tragic picture of the TCCL that was, So what is the situation of the tannery industry in Chennai? Okay, I feel that there are more of inorganized. Even you know that this wastewater is toxic. You have chromium wastewater, is chromium there. How this current situation in terms of managing their wastewater, because this problem is not new, it's been there, I think, generations, I can say, so yeah.
I will not put all the industries on a generic platform. There are genuine industrialists who want to treat their waste and bring something good out of it. But on a large scale, like this waste treatment is given the least preference in any industrial process. I would say that there should be a lot of more uh, streamlining of the work, and more policies and especially implementation of policies has to be brought forth by the Pollution Control Board norms. It is just not the policymakers, it should also be the industrialists and the researchers working together on that, and there should be a collective responsibility among the industries to work on this problem and put an end to this problem. It is not only like they feel that they're spending a lot on industrial waste effluent or the waste treatment, which gives them any revenue. It is not like that. If you think collectively, it involves a lot of job opportunities, research opportunities for people to come together as in Western countries, and it in turn involves in the economic development of the country as well.
Well, I'm more into the because these tanneries are small scale, and I think they're all clustered together, right, in the one area. Yeah, is it right? Yeah,
it is right.
And yeah, so the level of understanding on the treatment of the wastewater is also one issue, I guess. Is it? Okay.
Yeah.
Because of course, big tanneries have resources. Small tanneries, they just discharge into wherever there's an extra water canal, the way put in pipe. So it's always an issue, in terms of the. It's not just only tanneries, textile industry. There's all kinds of industries when they are small and medium scale, there is always challenge about the resources. Okay, in terms of implementing the wastewater, we have a policies everywhere there are. I think everybody use the BOD 5 or BOD 3. You have these, enforcement is another issues over there. Yeah. Okay, let's talk about your research area. And
you have CEPTs as well, which is when there are cluster of small industries like that. There are exceptions. You have CEPTs, centralized effluent treatment plants, which are working, and they're doing a good job in some places, not everywhere.
Yeah, well, we're talking about the failure systems only. Of course, there every industry, I mean, every segment, successful studies are there, successful cases are there. Yeah. Let's look into your, you use your research synthetic wastewater or real wastewater from the plant?
As of now, I use synthetic wastewater because I need the predictability in results for publishing and patenting. I do, or it's not that I do have plans. I will be definitely moving on to the real-time effluent, wherein after my concrete results are obtained, I'll be testing it and I'll be seeing the deviations and what could be made to improve those deviations from the synthetic effluent to the real effluent.
I see that speak is more preferable compared to the Nafion in terms of the membrane.
Yes, it could be easily synthesized in laboratory conditions and it is economic and the results are better.
Yeah, BOD removal is much higher than the so in the Nafion. Yeah, so yeah. And you maintained what kind of concentration you use in chromium synthetic in the synthetic wastewater?
Initially, we used 100% concentrations, but then we will be reducing the concentrations to desired levels. Some 3% concentrations, which I would like to publish later in the paper and then test the efficiency.
Yeah, so this looks like a very, I understand it is still in the laboratory stage. It looks like a more economical solution for the industries in the future when it gets move into the pilot and understand the pure economics of in operating it, because it you can recover metal. Did you talk how much metal can be recovered? It's max 100% or what is the
It
level?
can be 100%. Definitely, I've not gone into that research. That is in future. That is my future plan. Then it cannot be 100% recovery. It could be any kind of percentage, but any small thing helps to offset.
Yeah.
And I would say that right now textile industries and tannery industries are interested in this project and they're just waiting for the results to come out and they would like to implement it in their industries. Textile industries in Coimbatore area and tannery industries in Ranipet Vellore area. Techniques.
Yeah, good. And you mentioned about, of course, MFCs. Okay, you can also recover energy. I think that you still have not done anything on those studies on energy recovery. Did you? Not yet.
We did, but I did not publish the results yet. It was about energy which is being about 5 volts of energy which is being produced, electricity which is being produced. But then that is not much for the industrial requirement. But then you cannot be lighting up the entire industry. Any small energy which is produced can be cascaded, or it can be given a voltage booster, and that can be used for that particular segment of the plant to run the electricity or to run the plant, and thus there is some percentage of offset in the use of conventional electricity.
There's one thing I always see in biological system is the growth of the bacteria. Okay, and particularly when you have this chromium, how did you manage the the acclimatization system in bacteria growth?
Okay. Now, first we go for the plating and treatment in the laboratory scale. We go for the conical flask and the overnight growth process, and then we check the efficiency, and based on that we isolate the we do the pre-work, and then we isolate the microbes, and then we go for the testing in the reactors.
But first the growth, it is sustain the growth continuously growing, or there is some bacteria will die, right? So
obviously every bacteria will have a life cycle, so constant supply or the regular supply of substrate is required for any growth or the proper bacterial growth and performance.
Good. And I didn't see that if the tannery is you have a lot of color issue also, right? We talked about before we make a presentation. And is also are you measuring any color issues also in this project?
Okay, an ideal hexavalent chromium will be about light to dark brown in color, and when you know that it is turned into trivalent chromium, the color turns to be green. So when there is a reduction of heavy metal, the color turns to green, and then again it has to go for further maybe probably a tertiary process of treatment to absorb your colors and improve your water quality.
So it's your measurement is based on the chromium concentration rather than it's not on the color index itself, so
yes.
See the industry always look at the perceptions, right? Oh, I can remove the color also. That makes this also the economical solution, yeah, because nobody wants to discharge color water into the
Correct.
into the
Correct.
public
Correct.
places. So yeah. Okay, super. Vijay, it's a nice, really good presentation. Thank you, giving presentation in this environment technology news hour. Before I end this session, would you like to give any final remarks to the audience?
Yes, my sincere thanks to Technobiz for giving me an opportunity to present my work. And audience, yes, I would like to say that, like, follow your heart, follow your dreams, and definitely you'll see it working someday. So that is how it has been for me, like, over the years. Like, I kept working on my dreams, and then, like, it's not like keep dreaming about it, like, start working on it and just take one step with, faith and confidence. Then you will see that your dreams are coming nearer you day by day.
Okay, thank you, Vijay. Guys, that's the end of the presentation on the bioelectrochemical cell for toxic wastewater treatment. Now you know who is working on it, Vijay. If you like to know more information, or you want to associate with Vijay or his department, or in chemical engineering department, the Hindustan Institute of Technology and Science, please reach out to the Vijay Samuel. It could be a big help providing solutions. He's also an environmental consultant. I'm sure that if you're looking for any advice on the pollution related problems, particularly on the water and wastewater, he's also working in the waste treatment also. So here is an expert, a knowledgeable person, Vijay Samuel, for you, and keep in touch with you. Yeah.
Hiram, I have one thing to discuss, like, if you don't mind. Like, I
Sure.
would like to talk about, Chemical Industry Association and the Indian Institute of Chemical Engineers I'm associated with professionally, because, like, I work with these two organizations, and, I'm also the joint secretary for the Chennai Regional Center. We work on, empowering students into, higher levels. Like, we give them internships, the real-time industry internships, and the online courses, and we give them the know-hows of the industry while their UG level itself. So students who are interested in, taking up internships and, industrial training can approach me in this regard as well.
So
Thank
it
you.
means that Indian Institute of Chemical Engineers, so now the prestige institute in the society, Chemical Engineering Society, which offers a number of educational programs, both for the students as well as the professionals in the industry as well.
Correct. Yes.
And also the Chemical Industry Association, CIA, is also based in. So Vijay is associated with this both organizations, supporting industry, in educating empowering the students as well as the technologists, right? Is it right when I'm making a sense of this, what I'm saying? Yeah.
It is also
Okay.
for the working technologists as well.
Yeah. So be in touch with these organizations as well, because they contribute. I think their role is very much noble and for the benefit of the industry and also the professionals. So I welcome you all to be part of this Indian Institute of Chemical Engineers as well as the Chemical Industry Association, and be part of their activities so that you gain benefit out of their programs. If you need more information, as you know, Vijay is he's a Secretary General of the Indian Institute of Chemical Engineers based in Chennai, and also is a part of this Chemical Industry Association. Okay, guys, that's the end of this episode of the Environment Technology News Hour. And if you like to watch this session again, you can always check on YouTube at the Technobiz channel. Feel free to check it out. I see you in the next episode. Thank you all. Bye bye for now.